All right, here we go. So in this video, we're covering slope, linear equations, and a little bit of exponentials too, and to connect all the dots between graphing. So take a notebook out, and let's take some notes first of all, and we'll do as many practice problems as time allows. All right, the first thing we want is the definition of slope. So this would be a good place to pause the video, copy this down to your note page so that you have this ready for you. All right, we got the rise over the run, and we have this formula of x2 minus x1. And on top we have y2 minus y1. All right, so this is a fraction. We got the top and the bottom. We want to understand that we have 2 points, all right? One of them, and each point always has 2 coordinates, right? We got x, y coordinates. So these 2 coordinates represent the first point. That's why they both have a 1. And these 2 coordinates represent the second point, and that's why they both have a 2. So again, we have an example here that you guys should write this down to have this in your notes, and we're going to have to do examples to make sure you know how to use this, all right? More time. So in this case, we finally have some numbers. So instead of just x1, y1, let's figure out how to label them. All right. We want to make sure that we understand that run is always going to go from the left to right. So think about the way the x and y axis works, right? A lot of times the x axis will be x and this will be y, okay? But as you guys get older, you can see this will be the time axis sometimes, right? We'll have time. And we understand which way time flows, right? Time only goes in one direction. That goes from left to right, yeah? So we want to always make sure that our run is going to consider that point 1 should be to the left of point 2. So the first thing we want to think about is which one of these numbers is bigger, 3 or 7? Okay, and since 7 is bigger, that means I'll use that as my x2, okay? So this one right here, we'll have 7 is our x2, okay? Sorry about that, we'll fix that, okay? And that means that 3 is our x1, okay? And so that makes this 7, 10 is the second point, so that's x2, y2. And then this one is going to be x1, y1. Sorry about that, all right? y1. So when we go put our numbers in, all we have to do is make sure that we switch in those specific values and that we pay attention to any double negatives that happen. So on the bottom, we have x2, and we see x2 is 7. And then we write minus, and we go look at what x1 is. In this case, we see x1 is 3. So we write 7 minus 3. So then y2, we have that as 10. And then y1 is 4. So on the top of this fraction, we have 10 minus 4, which is 6. And on the bottom, we have 7 minus 3, which is 4. Okay? And then occasionally, you have to break down a fraction all the way. So we should understand that this is the same as 2 times 3. Over 2 times 2, and I can cancel out the 2's so that we can get left to have 3 over 2 is our rise over run. All right. So in this example, we would have our slope, our m, would be equal to 3 over 2. All right. And I know it would be nice if we use the letter S to stand for slope, but we don't. All right. In this country, we use m, and in most countries, I believe they use m. So we just got to live with it. All right. So just know that m is the letter that we use for slope. So the next thing we're doing is to take a look at the geometric version of what we just did with numbers, okay? In this case, we have a picture so that we can see what we just did, okay? So let's do a different example, all right? We see that what I want to do is get from this point that's on this line back to this other point. So to calculate the rise and run between these points, the first thing that I want to do is do the run. Okay, so we always do our run to the right. So I highly recommend you start at the leftmost point and then make your run go to the right. And I can see that if I go to the right 4 steps, I will then be able to go straight down and I could get back to that other point. So in this case, I see that my run is 4, right? That's my run. And my rise is -2 because instead of going up, it's going down. So again, in this case, I would write 4 and then -2. Okay, but we could break this fraction down also because we got 2 times 2 over 2 times -1. Okay, so if I factor out my 2's, you see that my final answer is -1/2. Okay, so there's a way that you can get slope using a picture. And it has to do with making a right triangle. So notice we make a right triangle, okay, and we always do the run first, and then we go down. Okay, so I hope this refreshes your memory from what we did in class that day. So now the next idea we want to talk about is the different types of slope, okay? Now as we talked about this, an increasing slope, all right, means that we think as time goes forward, are we going up or down, right? So if it goes forward as we go to the right, then we call that a positive slope. But if it goes down as we go to the right, then we call that a negative slope, all right? A horizontal line has a slope of 0. And a vertical line has an undefined slope. We don't even say what the slope is. It doesn't exist, all right? So in this case, vertical lines are a little special, and we'll talk about those when we get there. So we want to, again, learn about this form called the slope-intercept form. So in this example, we should know that slope-intercept form is this idea of y equals mx plus b, okay? And we know that m is the slope. So looking at this example, I can see that m is equal to -3, and we know b is our y-intercept, so that's +3. So in this case, what I have to do is do y equals -3 from my m, and then the only value I change is the b, which is +3. Okay, so I can directly choose the answer by choosing D like this, right? But I also think it's just as important for you guys to indirectly choose the answer by crossing things out. So one reason why I can cross out C is because the slope in this one is 1, okay? But we wanted to find a slope of -3, so it can't be this one. Okay, we also notice that in A, this slope is +3, so it can't be this one either because we needed a -3. And we see in option B, we have a slope of -1, and the 1 is invisible, so it can't be that one either. So I hope you guys can see that process of elimination is pretty easy. You just have to know what you're looking for. All right. Likewise, on this option C, I see that I could cross out this one because it wants a slope of -5/3. So I know I could cross out this one, I could cross out this one, and this one. Because the only one that has the slope in the correct location is right here, okay, A. So A must be the answer for this example. Okay, so now that we talked about some of those ideas, we have a graphical concept here, okay? So we know that y equals mx plus b is our formula, okay? And we know we have this idea of slope and y-intercept, right? So if we look at the picture now, how do I pick what the answer has to be? What if we go backwards? What if instead of giving you guys the equation, having you draw the picture, I give you the picture and tell you to give me the equation? So the whole point of this slide is to teach you guys what the y-intercept means when we look at it on the graph, right? What this means is that this point right here, 2, is where the blue line crosses the red line, the y-axis, okay? So the y-axis is the red line. The blue line intercepts that at this point right here that I'm going to circle with a +2, okay? So we're looking for one of these equations that have a y-intercept of 2. So again, this will be the one where it says +2 at the end. I can cross out B then, because that's definitely not that. So now I have to make my choice between A, C, and D. All of these all have a y-intercept of 2. So now we'll have to go look at the slope right now, right? So to do that, we want to talk about this idea of lattice points that we talked about earlier in class today. And so lattice points are going to be these kind of points. Points that are where the grid lines cross, okay? So they're going to be points with integer coordinates. So all of these kind of points that I'm darkening, okay, these are all lattice points. You got me? Okay, all the ones I did in red are lattice points. In blue, I'm going to do some example of ones that are not lattice points, okay? Like a point right here. Even a point right there isn't a lattice point, okay? It has to be where 2 of the grid lines cross. So none of these are lattice points, okay? It has to be exactly where they cross. So to do this one, I want to make sure that I use 2 lattice points so that I know what I'm counting, okay? So we'll start at the y-intercept. And I just want to follow on my blue line until I see another lattice point, right? And the next one that I see is right here. All right, so you see I'm darkening that point right there. So those are 2 lattice points on the line that I'm trying to figure out. And so what we're going to do right now is basically count to get our slope, right? And so we know it's rise over run. So I've been telling you guys, do the run first. So we always go to the right. Our run should always be positive. So if I take 2 steps to the right and 3 steps down, that gives me a -3, right? That means that I have my slope. So I can see the way that this should look is that we should have y equals, and our slope, our run is 2, and our rise is -3. So our answer for this one should be option D, okay? Again, it can't be A because this one is not negative, right? That's a positive 3 over 2. And this one has a slope of positive 1. So it can't be that one either. Now we see the next one. Okay, we're going to look at point slope. So this is a new idea. Okay, we got the point slope slide. There's only a couple questions on this on the final. So I'm going to kind of cover it, but I'm not going to go so deep into it, right? The idea is that we have this equation. We need to have one point, the coordinates of one point that's on the line, and we want to have the slope of the line, and then we can use the point slope form. So what I'm going to do right now is jump into Desmos, and I'm going to show you guys what I mean by adding this point, 2, 3, and I put that in red, okay? And we're going to go talk about how I can make a line that goes through that. So in this case, notice I have the point 2, 3, okay? So let's say I wanted to have a line that goes through that with the slope of 2, okay? So where m equals 2. You see that? Well, right now, look, it's going straight through that point, right? So when I put all this stuff together, we can say that if I change the slope, it might not go through there. What if I have a slope of 4? It doesn't go through this point anymore, right? So as the slope of a line changes the tilt of it, right? It changes, does it go straight up or does it go more flat, right? Okay, whereas we notice that what these two numbers are going to do is they're going to tell us another point that has to be on the line, okay? So in this case, what we have is this point 2, 3. So let's say that we want to do this example like we have right here in our equation, okay? I want to make a line that goes through 2, 3, but let's give it a slope, all right? So let's say that we have a slope of, let's call it 4, okay? And we'll adjust everything around that. So let's have m equals 4, okay? And we're going to go find this. We want a line with m equals 4, okay, that goes through the point 2 and 3. Okay, so let's go figure out how to do this. How do I have a slope that goes through that? So if I want my slope to be 4, we're going to change m to be equal to 4. Okay, now notice this point does not go through there. Okay, but what I want to do now is change my y1 to be equal to the y value. So notice our y1 is 3. So we're going to go to y1 and we're going to increase that to be 3. Okay, now for x1 we want x1 to be 2. Notice when I change this equation to be 2, it goes straight through the point that we want, okay? So this is the way this equation works. All you got to do is adjust those two values. So let's go do it numerically instead of using the technology so you guys can see how it works that way. Alright, so now okay, so what we're going to do now is by hand we're going to go through and write the equation of a line that goes through 2, 3, but has a slope of 4. Okay, so we want to understand that this is our x1 and that's our y1. Okay, so now we just drop everything where it goes. I'm going to do y minus y1. Okay, but y1 is 3. So I write y minus 3. Then I write equals m. Okay, and we got to remember that m is our slope, right? Remember that? So our slope, it says, is 4. So now I write 4, and then I put a blank parenthesis. Okay, then I copy the x. Again, the only things that we switch out are this one, and the m, right? We switch out the y1, the m, and the x, the x1. So now instead of writing minus x1, I'm going to write minus 2, because x1 is 2. And in this case, the problem is complete. All right, this is already it. This is the equation of a line that goes through this point and has a slope of 4. All right. I've been trying to get you guys to notice one thing, right? I want you guys to focus on the fact that the 2 goes into parentheses with x, and that is the x coordinate, right? Okay. Notice that the y coordinate ends up going with the y. Okay. Another thing you want to notice is that over here, these are going to have opposite signs. Okay. This was a positive 3. And right now, look, it's a negative 3. Here we have a positive 2, right? And here, it's a negative 2. So we're going to be changing signs of each coordinate when we do those. And that's like the one thing you want to make sure that you do correctly, because it'll be a shame if you forget to just move a negative sign. Okay, so now we're talking about linear versus exponential functions, okay? We want to understand that a linear function has the same growth rate, okay? So it's always going to have the same slope. So on 43, I want you guys to notice how this is going over 2, up 1, over 2, up 1, over 2, up 1, over 2, up 1, over and over and over again. It's always going over 2 and up 1, okay? So not only does this look exactly like a line, which is what linear means, right? In mathematics, linear means exactly like a line, right? So we're going to choose linear for this function, whereas in 44, we see that this is exponential growth, all right? Whenever some curve goes up like this really fast, and especially the fact that you see a curve right here, notice this is not straight, okay, we know that this cannot be a line, all right? So the only option that you're going to have on your multiple choice would be for you to understand that this is exponential, and therefore it's not linear. All right, so you should be able to at least cross out linear because you know that linear means line. Okay, the next thing we did is we talked about exponential functions numerically, right? So what we want to understand is these two tables each represent a different kind of function, okay? When we were doing our sequences, we had a different idea, right? We saw that if I'm adding 4 every time, we called that an arithmetic sequence, right? But if I had to, if I had a different value and it wasn't adding the same value every time, then it was not called arithmetic, okay? So what we want to do is recognize that this is a line. This is exactly the way a line works, like how I just showed you. It's always going to go up and over the same amount. So again, this is linear, and I want you guys to understand that linear is basically the same idea as an arithmetic sequence. Okay, so just use that idea. If we're adding the same value every time, we call that linear. And then now, we can tell we're definitely not adding the same value every time, right? But in this case, we're multiplying by 3 every time, right? 6 times 3 is 18, and 18 times 3 is 54. And so we can see that this one is not adding the same value, but it's multiplying, okay? So in this case, we call this exponential. Okay, and exponential growth is the kind of things that we use to model, you know, a sickness or population growth or maybe even radioactive decay or something like that. So as we get through this one, I want you guys to understand that exponential is the same thing as geometric. So all I'm going to do is just write geometric underneath here in like parentheses for you guys to understand that these are the same idea, right? Put it in blue. All right, geometric sequences give us this exponential idea. All right. So as I go through here, you guys have a couple examples that are just like this. So just make sure that you understand your table should be counting one at a time. You just want to see what's going on in the Y column. Okay, so just look at the Y column and figure out how much they're changing. So in this case, we're talking now about graphing things. Okay, so I want you guys to notice how the point 0, 2 is on the blue graph. You see that? Okay, what this means is that this red point, okay, the point 0, 2, the x coordinate 0 and the y coordinate, look, is up 2. So this point right here. Okay, this tells us that f of 0 is 2, which means that when I plug in 0 to my function, I better get 2 out. But the meaning of this green point is that when I plug in 1, right, notice 1 is right here, I have to go up all the way to 6. So this one is telling me that f of 1 is equal to 6. So we would want to choose the answer here that when I plug in 0, gives me 2, but when I plug in 1, I get 6. So in this example, we're going to calculate by hand how to tell which one of these graphs would correspond to which equation down here. All right, so we want to realize that this tells us again that this red point is on the graph, and so the coordinates of this red point, right, are x equals 0 and y equals 2. All right, and the coordinates of this point over here, the green point, are x equals 1 and y equals 6. Okay, so like we said, this red point, this one right here, is telling us that f of 0 is equal to 2. Whereas this one over here is telling us that f of 1 is equal to 6, right? So we want to tell which one of these it is, all right? And one of the big ideas that we talked about today is that what is any number to the 0 power, right? 1 to the 0 is 1. 2 to the 0 is 1. 3 to the 0 is 1, okay? So any number that we take to the 0 power is equal to 1. So we're going to need this to do this work right here because we have all these examples, right? So we could go one at a time, and we can try the first one right there. We can try A. Okay, so what if we just naively had to go one at a time and try all of them? So the first thing we'll do is check to see whether or not this one works. So let's just look at it. F of x equals 4 times 2 to the x. All right, so what's going to happen now is we'll go plug in 0 and see what happens when I do that input, right? I get 4 times 2 to the 0. All right, and anything to the 0 is 1. So this means 4 times 1. And 4 times 1 is 4, which is not equal to what we wanted. We wanted to get 2. So I know that A can't be the answer. It just can't be that. It's got to be something else. Okay, so now we'll go pick another one. All right, so as we look through the rest of them, we'll try this one. Let's see if it's B, okay? So we got F of x equals 2 times 3 to the x, okay? And then we'll just go plug in 0 to see if we get the correct value. Okay, but when I do 2 times 3 to the 0, again, notice that the x used to be an x and now it's a 0, and this used to be an x and now it's a 0, so we changed those, right? Well, this is equal to 2 times 1, and 2 times 1 is equal to 2. So in this case, we have exactly what we wanted, right? We wanted to get f of 0 equals 2, okay? So that's good, but we should also notice that this option also gives us 2, right? So we have a problem, right? Because both of those will give us the same value. So notice that if I change this to 4, and I do 2 times 4 to the 0, this means I'm doing 2 times 1, and I get 2 again. So now, I know it's got to be one of these two, B or D, okay? And we have to choose between them. Which one has it got to be? Well, we know it can't be C, and the reason why we know it can't be C is because when I do that one, let's go see what that'll look like, right? If I plug in 5 times 2 to the x, and then I go use the idea that that's 5 times 2 to the 0, but we know 2 to the 0 is 1, so this is 5 times 1, and that's just 5, okay? So this is not equal to 2. So that means I can't have C either. You see what I mean? So it's got to be B or D. It's got to be one of these, all right? So let's go look at what happens if we go check the next step, okay? The next thing that we'd have to look at is what is f of 1, right? So let's go back to this function, 2 times 3 to the x, okay? When I go through and do this, I see that I have to do a 1 now, okay? So we'll do 2 times 3 to the 1. All right, but anything to the 1 power is itself, and so that is going to end up being stuck as 2 times 3, and that gives me 6, okay? But we see that's what I wanted, right? When I plug in 1, I get 6, and when I plug in 0, I get 2. So we see our answer has to be B, okay? And we could also notice that if I did have x equals 1, this would end up being 2 times 4, which is 8, and that's not equal to the 6 that we wanted to get right here. So, I mean, that's why it can't be D either. All right, so that was a pretty good review for you guys to understand the way this works. There's only a couple problems on the test about this, so if you got more questions, feel free to ask me in class tomorrow. All right, the video's already going a little over, but we're just going to have to roll with the punches here. So the next thing I got is this little picture that's meant to explain to you guys what happens on domain and range. So this would be a good time to pause the video and take a look, right? That we see that this is a hole. And so remember that that gives us a strictly less than when it's a hole. And then when we have a point that's not filled in, right? When it's a hole, this corresponds to a round parentheses instead of a square bracket, right? The square bracket goes with the points that are filled in and are solid, okay? And that's the same thing as less than or equal to. In this case is what we want, okay? Notice in this one how this point is filled in and solid. And so now that's why we have a less than or equal to right here. And in this case, we notice that because this is filled in, the one on the left is a square bracket, right? And because this is a hole on the right, the one on the right is going to be a round parentheses. Okay, so don't forget that this is called interval notation. You can go back to the video part 3 of functions, and that'll tell you more about this. If you want to go more in detail about intervals, take a look at that. Okay, but what we want to do now to finish up this video today, I'm going to cut it off after I do a few of these problems. It's going to be to get the interval of this domain right here. Okay, so we want to remember that what domain meant, okay, when I'm doing my interval notation is I want to put the leftmost point and the rightmost point, okay? So domain is about the x values that we can possibly have as input, right? So our leftmost point is -7, and our rightmost point is +7, okay? So I know that I have a -7 and a +7, but the thing I got to figure out now is, do I use round parentheses or square brackets, right? Well, you see how this one is a hole, right? So that means I use a round parentheses on that one. Notice this one is filled in. So in that one, I use a square bracket, and I'm hoping that, you guys still remember that from the last unit. Okay, so domain is the leftmost and the rightmost point. All right? And so now when we get range, we want to understand what the range is going to be. Okay? And for us, the range will be the set of possible y values that we get as output. So now when we look at this, we want to consider the range goes from the minimum point to the maximum value, okay? So the minimum means like the lowest point, okay? And if you could see right now on this graph, the lowest point is right here, okay? And that goes to a value of -4. That's what makes it the lowest, right? The highest point is actually not this point at the end. The highest point is right here, right? And notice that corresponds with a value of 3. So because both of these points are actually solid, notice there's no hole right here, right? That's just a regular point. So in this case, my interval is going to be 2 square brackets, okay? The lowest value is -4, and the highest value is +3. So this would be a way that we represent the range of this function that we're looking at. Okay, so I'm hoping thinking about this could help you out a little bit on those examples. All right, the next thing that I'm talking about here, and I didn't want to go too much overtime, so I'm getting used to trying to do this right now, is we want to understand what happens with this specific example, right? So think about this right here, okay? The input and the output. If I want to find f of 0, what that means is that I have to input 0 into my function that we're talking about. Like, what is f? F is this thing over here. F is saying to take whatever number you input and multiply it by -3, and then right after that you add 6 to it, okay? So let's go do that. That means f of 0, instead of being 3 times x, is 3 times 0. And that just makes 0. And then if I add 6 to that, I get 6. So we said f of 0 must be equal to 6, and that's our answer right here for A. Okay? This would be a good example of problems that you guys could do, right? If we want to find f of -7, then I plug in -7 right here. -7 plus 3 gives me -4. You could be able to do a lot of these in your head, right? F of 1 means I plug in 1 for x. -2 times 1 is -2. So the answer here is B. In this case, you see if I plug in 0, then I do 4 times 0. And that makes 0. And 0 minus 2 is just -2. Okay, so don't forget about that relationship between input and output. If you're shaky on this topic, you might want to go back and watch the videos on functions. Okay, now tell me real quick, we'll wrap up the video with this one, okay? What is this point, okay? Is the point 3, 3 a maximum or a minimum? Okay, you guys got one problem like this on the test where it's going to ask you whether or not that's a maximum or minimum. Okay, well notice that there's no value that comes above this one. Okay, so in this case we would want to say that this is a maximum. Alright? Now I feel like I might be able to get away with one more, so I'm sorry, I'm going to push the video toward one more example. Let's get this last one and finish up what I had in mind. Okay, for which interval is this function decreasing? Okay, and so decreasing means that it's going down and that it's less and less and less. So notice in this case it's being constant, it's not changing. And in this interval it's going up, in this interval it's constant again. But all the way from here to here, notice how it's going down, right? So in this case we want to understand what our interval is, okay? You guys see how this point is a hole? So that means that -4 is going to be our rightmost endpoint, okay, for this interval that's decreasing. But you want to also notice that this graph has an arrow that's showing that it's going to be going up forever as we go to the left. Which means as we go to the right, look at this thing is going down, okay? So the answer that goes right here, you might not have guessed it, is -infinity, okay? That's the interval that makes this function decreasing, all right? So notice this word in here that I had increasing, forget about that. We're going to stick to this question that I wrote on the side, okay? For which interval is the function decreasing? Now we'll get back into the last question to wrap this thing up, and I'm sorry it went a little bit over, but let's consider, when is this function increasing? So let's forget about that, and let's change the word to increasing. All right, the same idea that I wrote on the actual paper over here, right? So in this case, we should be able to see that the only time that it's going up, like we always think of left to right. So this thing is going down as I go to the right, so that's decreasing. Then it's staying flat, so it's definitely not increasing. The only time that it increases is in between this zone right here, right? That's where it increases. So because I have a hole at this point, right, that's -1. So that tells me I have a parentheses for -1, and then a comma, and because this is also a hole, I see that this is 3. And so that's going to be a +3, but with the round parentheses again, because both of those points right here, these are both holes. So they'll both end up being around parentheses again. This is how interval notation works. We don't want to confuse an interval with a point, and it's really easy to get them confused. And so what you have to know is this word, right? You have to know this word or you're not going to understand, okay? So understand that you guys have a little bit of things left to study. I wish you guys luck studying on this thing. Let me know if you got any questions tomorrow. Take notes on this. Watch it again if you need to. And even go brush up on other videos if you feel like there's something that got you confused. All right, good luck, everybody.